Hey, Algebra 1, Mr. Catlin here with your help on lesson 14. I didn't get to see first period today, so I'm going to make this a little bit longer than normal. So, second period, you might want to zoom to where maybe I get to answering these, but I just want to quickly review percent change because that's what this lesson's about. It's about recalling whenever we talked about percent change in seventh grade. So a lot of you in my first period I had in class last year anyway. So hopefully this will ring a bell. But we did percent change and we based it off of the idea with a double number line. All right. So I'm going to do just a basic example before I jump into the questions. So with a double number line, we always had on the bottom was our percentage, 0 to 100%, and then we might have like a dollar value or something that we were changing from an original to a different amount. And it always had 0 here to match, but the 100% based upon, where you were to begin. So like for example, let's just do a very simple example here. Let's say that you had a $20 bill for eating out, okay? And that's 100% of your bill. You had $20 worth of food and drink. And if you wanted to, find out what that would be like with a tip, you're supposed to tip, on a bill if they do a good job, 15 to 20%. For the argument's sake, let's do a simple idea and let's just do 20%. So a couple of ideas that you could do is you could say, well, I can find what 20% of $20 is, and that would be 4 because we're breaking this down into fifths, 20, 40, 60, 80, 100. So we divide 20 by 5 to find out that there would be 4, and then we could add 4 to the $20 and know that that's 24. Or the other idea, and this is really going to tie in with what we're doing now, is this would be 24. That $24 could be thought of adding 20% to the 100 as 120%. So when we talk about percent increase, we can go over the 100%. And if we're talking about going below it, we can go under it, like taking away, right? So this double number line kind of gives us that idea. And the idea that we're going to tackle today is, well, I could have done this problem by finding 20% of multiplying by $20 to find that 4, right? And then take that $4 and add it back to the $20 that I paid for the meal in the first place and get 24. But a shortcut and a much more efficient way to get to that 24 is to not think of it as finding 20% and adding the 4, but finding out what 120% and doing the plus 20 in your head over the 100. And that would have looked like this. I'm going to find 120% of $20, and that will get me straight to my answer of 24. So, this idea of, doing your percentage before in your head with plus and minus, and then multiplying by that to get your exact amount that you need for the percent change is going to be helpful when we look at these functions of exponential relationships. So, let's see if we can put that into effect here with this. I know that was kind of a long introduction, but here we go. A book cost $45. Sales tax on the book is 7%. Write two different expressions that represent the final cost of the book in dollars. One of the expressions should use only a single multiplication and no other operations. I'm making a video, so I'll stay quiet for a second, okay? Um, my daughter came rolling in on roller skates, and she's super excited. Oh, cool. I'll be done in just a second. Okay. Don't let them leave without me. Don't let them leave without me seeing them. Oh, then I will see them. All right, so $45 is the price and a 7% tax. We could take $45, multiply it by 0.07. That would tell us how much money they're going to tax us. All right, and I think I've already got that put into the calculator here. Okay, that's $3.15. So $3.15. Now we could take that amount and add that to the $45 that we started with, and that would give us $45 or $48.15. We could do it that way, right? One step at multiply and then add. And I think they wanted you to do it as an expression. So that expression would have looked something like this. 45 times 0.07 plus 45, right? It would look like that. And that would have given us what it would have equaled. But instead of making it into two operations, we could have bypassed the addition and multiplied 45 by 7% over the 100, kind of like we thought about over here, and multiply it by 1.07. And that would also, as I show here on Desmos, 45 times 1.07 is 4815. So that gives you the same amount, 4815, just the same way that we would have seen the other way. So the two expressions are multiply and then add, or just multiply by the proper percentage that's over what you're talking about. And we can apply that the same on number 2 here. A cake costs $32 and is on sale for 15% off. And there are no taxes, so we don't have to worry about an increase. This is 15% off, so we're dropping money. Explain why the expression 85 hundredths times 0.32 represents the final price of the cake in dollars. 0.85 equals 85%. You are paying 85% if you save 15% off from 100%. That's the way that we think about this. So we're thinking about this in terms of what we pay and not in terms of what we save. And so this represents the final price because it's what you pay. It's not how much you saved. So if we wanted to find out how much we'd saved, we multiply by 0.15 and 32. We also could do that and subtract it from 32 and find the answer. But if we want to jump straight to the final price, we can just multiply these two numbers. This idea is going to save us a lot of time as we start to look at these exponential functions that do multiplications of percentages over and over and over and over and over again. All right? That's all I got. I hope it was helpful. I hate that I missed first period today, but I think you guys will be able to jump right in with where we're starting in lesson 14 tomorrow. All right, see ya.